Welcome to my presentation. In this presentation, we shall try to see how to simplify problems related to exponents using the laws of exponents. So let us take an example here. And in this example, we want to simplify, let me write this, we want to simplify 5 over a to the power of 2, this whole thing raised to the power of 3. So the way to solve this is as follows. We'll use these steps to be able to simplify these types of problems. As the first step, we're going to use the quotient rule, and the quotient rule of the laws of exponents is telling us that if we have a ratio a over b, and if this is raised to the power of m, every one of the terms inside the parentheses will be raised to their power, a to the power of m divided by b to the power of m. We will use this the law of exponent to be able to, and then apply it to this particular problem. What we have here is 5 over a to the power of 2. This whole thing is raised to the power of 3. Every one of the terms will be raised to the power of 3. The numerator, which is 5, will be raised to the power of 3. And in the denominator, we have a to the power of 2, and that will be raised to the power of 3. As we know, there is we know another law of an exponent which says if we have a to the power of m, and if this exponent is raised to another exponent, we can write the base term once and then multiply the power terms m times n. So we're going to use that in the denominator part of it. So we can simplify this as 5 to the power of 3 divided by a to the power of 2 times 3, right? So therefore we can write this as, now we want to expand 5 to the power of 3. How do we, let me state it right here. 5 to the power of 3 I can write as 5 times 5 times 5 divided by a to the power of 6. Therefore I can come back here and then simplify it some more. 5 times 5 is 25. 25 times 5 is 125 divided by a to the power of 6. And this is our answer. This is where we want to leave it. So therefore, when we had 5 over a to the power of 2, the whole thing raised to the power of 3, when we used two the laws of exponents in here. We used the quotient rule, and we also used the power rule. So therefore, to simplify an example of this type, we can use more than one laws to be able to solve the problem. Sometimes it may so happen that we may have to use more than one rule to be able to solve a problem, and this is a good example of that type of a situation. Let's look at another example. In here, let us say, we'll take another example. In this example, we want to simplify 3a to the power of negative 2 divided by b to the power of 3. This whole thing is raised to the power of negative 4. Okay, so we will apply the laws of exponents to be able to simplify this particular problem, this particular example. Step number 1. We want to recognize that there is a, inside the parentheses, we have a ratio. We have a numerator part and we have a denominator part. And therefore, first step, we want to use the quotient rule. And what is the quotient rule telling us? If we have a ratio a over b, and if this ratio is raised to the power of m, we're going to raise every one of the terms inside the parentheses to that power as a to the power of m divided by b to the power of m. And therefore, we're going to apply this rule first to simplify the numerator parts and simplify the denominator parts. In the numerator, we have 3a to the power of negative 2, and this whole thing is going to be raised to the power of negative 4. And in the denominator part, we have b to the power of 3, and this whole thing is raised to the power of negative 4. And therefore, now we can simplify this. every one of the terms in the numerator part will be raised to the power of negative 4. So the rule which we know here is this: if we have a a product like this, a times b, and if this product is raised to the power of m, every one of the terms will be raised to that power, a to the power of m, and then also times b to the power of m. Every one of the terms inside the parentheses will be raised to that power. There is another rule which we're going to use here, and that is the power rule. If we have a to the power of m, if we have an exponent, if this exponent is raised to another exponent, we're going to write the base term once and then multiply the power terms like that. So these are the different rules which we're going to apply to this particular example to simplify it. So therefore, in the numerator part, we can write that as step number 3, and then we will write that part here: 3 raised to the power of negative 4 times a to the power of negative 2, this whole thing is raised to the power of negative 4, divided by b to the power of 3 times negative 4, like that. So therefore, we can come back here and simplify this some more. We can write this as 1 over 3 to the power of positive 4, 3 to the power of negative 4. When we bring the exponent to the denominator, the negative exponent changes to a positive exponent, and therefore we can express 3 to the power of negative 4 as 1 over 3 to the power of positive 4. And in the numerator, we have a to the power of negative 2 times negative 4. I'll keep that in the numerator because that is going to turn to a positive. And in the denominator, we have b to the power of 3 times negative 4, which will be equal to negative 12. Let me write that negative 12 here. B to the power of negative 12. So therefore, I can simplify this some more as a to the power of positive 8, negative 4 times negative 2 is positive 8, and 3 to the power of 4, I have, if we were to simplify 3 to the power of 4, we can write this as 3 times 3 times 3 times 3. 3 to the power of 4, the base term is 3, the exponential term is 4, according to the exponential rules. The number of times the base term needs to be repeated is given to us in the exponential term, and therefore 3 to the power of 4 can be written out as 3 times 3 times 3 times 3, and therefore when we simplify this, it's going to be 3 times 3 is 9, 3 times 3 is 9, 9 times 9 is 81, and therefore 3 to the power of 4 is equal to 81. We can write that as 81. And then since I have 1 over b to the power of negative 12, I can express this as a positive exponent by bringing it to the numerator and then writing it out as b to the power of positive 12. So since I have an exponential term in the denominator, when I bring it up to the numerator, it becomes a positive exponent. So therefore, I can write this one as b to the power of 12. So therefore, our answer is a to the power of 8 times b to the power of 12 divided by 81. That is where we want to leave it, and this is our answer. So in here we have used multiple laws of exponents to be able to simplify this problem. This is the way we want to use the laws to be able to simplify problems involving exponents. In my next presentation, we shall look at some more examples as to how to solve exponents using the laws of exponents.